Hello, ladies and gentlemen. This is Mr. McNair, and this is a short lesson on solving systems of linear inequalities. Now, a system is going to involve more than one, so we're going to be taking more than one linear inequality and putting it on the same coordinate plane. For example, here we have y is less than 2, x is greater than or equal to negative 1, and y is greater than x minus 2. So we're going to take these, let's graph them one at a time and see where their regions intersect. So if we start off with the first one, y is less than 2, you should be able to look at that inequality and tell me, because it's y, just a y in there, that is horizontal. And then also that that's going to be a dotted line. So we're going to make a dotted horizontal line through y equals 2. So let's make our dotted line here through y equals 2. All right. Now, this inequality is a less than, so we're going to be shading below the line. So that's going to be everything below this line. I usually make these little tassel marks. If you really wanted to, you could technically go through there and shade the whole thing if you wanted. I personally don't like doing that when I have a pencil, just because it generally messes up the area. Like you can't see all of the different inequalities well. So I'm just gonna stay with my tassels. All right. So next inequality that we have. The next inequality we have is x is greater than or equal to negative 1. We should be able to look at that and say, okay, that's vertical because it's just an x. And we should also be able to say that that is going to be a solid vertical line, and that's going to go through x equals negative 1. So that's going to be the solid vertical line through x equals negative 1. Here that is. After that, we're going to do our shading. That's x is greater than or equal to negative 1. So since it's greater than or equal to negative 1, we're going to shade to the right, because all of the things that are bigger than negative 1 are on this side. All right, our last inequality that we have, y is greater than x minus 2. All right, just by looking at that inequality, we know that it's in slope-intercept form already, and the y-intercept is negative 2. The slope is 1 over 1. So we take our y-intercept and we put it on the y-axis. So negative 2 on the y-axis. And then from there we make our more points using the slope. The slope is 1 over 1, so we go up 1 over 1, up 1 over 1. Or we could have also went down 1, left 1, down 1, left 1. Now, again, looking at our inequality symbol, it's just a greater than. So we're going to connect this with a dotted line. So we're going to connect all of our dots here with a dotted line. Again, looking at the symbol, again, it's greater than, so we're going to shade above the line. And there that is. Now our answer is going to be where all of those shades intersect. Okay? And we see that all of those shades, the red, the green, and the blue, they all intersect in this triangle in here. All in there. Okay? So that's our solution region. Okay? So that will be your answer. You're done. Now, you could technically check your answer by picking a point in this region and making sure that it works in all three inequalities. So the point that I picked here is 0, 0, because, once again, it's in our solution region. So 0 for the x, 0 for the y. And when you plug those in, you should see that they work. When you plug it into the first equation, or the first inequality, you get 0 is less than 2, which is true. When you plug it into the second inequality, you get 0 is greater than or equal to negative 1, which is also true. And when you plug it into inequality 3, you get 0 is greater than 0 minus 2. Well, if you simplify that, that's 0 is greater than negative 2, which is also true. So it works in all three inequalities, so you know that your region is graphed correctly. All right, let's move on. Let's try one more. Here, we have 4 inequalities. The first inequality we know that this is going to be a vertical line. We also know that it's going to be solid because there's a line under it. Okay, so we're going to make a solid vertical line through x equals 1. And there that is. Now, because it is a greater than or equal to, we're going to shade to the right. So that's going to be all of the stuff shaded to the right. Once again, that's that whole region shaded to the right of that line. Our next inequality that we have is x is less than 4. Again, this is going to be vertical because it's going to be because it's just x equals. So we're going to make a vertical line. This time it's going to be dotted because there's no line under it. So we have a dotted vertical line through x equals 4. So here that is there. Dotted vertical line through x equals 4. This is x is less than 4. Less than 4. So we're going to be shading to the left because that's all of the things that are less than 4. Okay? Next inequality that we have, y is greater than negative 1. Because it's y, we know that it's going to be horizontal. Okay? And because it's just a greater than and there's not a greater than or equal to, we know that it's going to be a dotted line. So a dotted horizontal line through negative 1. So that's going to look like that. Because it's a greater than symbol, we're going to shade above the line because greater than is above. Now you want to start looking and seeing where the shades intersect so far. So far, we see that our shades intersect in this region here. This is the region so far where our shading is intersecting. So far, it's all in that region. Okay? All right, let's go to our next and final inequality. Our final inequality is x minus 2y is greater than or equal to negative 2. Now, what I would do with this one, I'm going to change up my color a little bit. First thing you would do is probably put this in slope-intercept form. So subtract x from both sides. We get negative 2y is greater than or equal to negative x minus 2. And then get y by itself by dividing by negative 2. And you divide everything by negative 2. So you get y. When you multiply or divide by negative, what do you have to do? Flip the inequality. So this becomes positive 1/2 because negative 1 over negative 2, a negative over a negative makes a positive. And then negative 2 over negative 2 is positive 1. So we'd have a y-intercept of 1 and a slope of 1/2. Okay? So let's go ahead and graph that. Y-intercept is 1. Here's 1 on our y-axis. Our slope is 1/2, so we're going to go up 1 over 2. Rise over run. Up 1 over 2. Up 1 over 2. Or we could have also went down 1, left 2. Down 1, left 2. Now we're going to go ahead and connect that with a solid line. Once again, because that's a less than or equal to. So we'll go ahead and make a solid line there. So here it is, solid line. Okay. And when you're graphing inequalities, don't forget, you determine where you shade by looking at the equation in slope-intercept form. So the inequality that we're looking at is the less than or equal to, this one here. Okay? So that's a less than or equal to, so we're going to shade below the line. So that will be all the stuff in here. All right? Now, always make sure that you highlight your region, that is your solution region. And that solution region is going to be this region here. Everything in this quadrilateral. Okay? And there you go. All right, once again, I would go ahead and pick a point inside that region just to make sure. So if I was to pick the point, let's see, what's a good point to pick? How about this one here? It's always nice to pick something with a 0 in it. That's the point 3, 0. So that's 3 for x, 0 for y. If I plug it into the top inequality, that would be 3 is greater than or equal to 1. So that's true. The next inequality here, That would be 3 is less than 4. That's true. Okay. The next inequality here, y is greater than negative 1. So y is 0. So that would be 0 is greater than negative 1. That's true. And our last inequality, x minus 2y is greater than or equal to negative 2. So that would be 0. Oh, excuse me, that's not 0. X is 3. So 3 minus 2 times 0 is greater than or equal to negative 2. Well, 2 times 0 is 0. So that's going to be 3 is greater than or equal to negative 2. Is that true? Yes. So it's true for all 4 inequalities. So we know that we're right. All right, good. Here, let's try this one. This one is a little different because they're asking us to go backwards. Instead of me giving you inequalities and asking you to graph it, here I've graphed it, and I want you to write the inequalities. So let's take these one at a time. Let's deal with the dotted line first. There's 2 things that you need when you're writing an equation or inequality in slope-intercept form. You need the y-intercept and you need the slope. So if we deal with the dotted line, we see that the y-intercept is there, and the y-intercept is negative 2. Now the reason it's negative 2 is because we're counting by 2's. If you notice, we're counting by 2's on our grid. All right, so we have a y-intercept of negative 2, and then after that, you need your slope. Your slope you always find by doing rise over run. So let's pick 2 points on our line, such as here and here. So from this point to this point, we had to go up 2 and then over 4. So the slope, remember slope is rise over run, is 2 over 4, which simplifies to 1/2. So the dotted line, the inequality it represents that will be y. We're not going to use equals because we're not doing an equation, we're doing an inequality. So let's just skip that for right now. Y, and then our mx plus b. All right, we have a dotted line, so there's no line under our inequality. And then if you notice, it's shaded above the line, so that's going to be greater than. Okay, so there's that line. Let's go to the solid line. The solid line, we have a y-intercept here of negative 4. And then again, you just pick 2 points to do your to find your slope. So here's a point, our y-intercept was a point, and here's another point. So from one point to the next, you had to go down 4 over 2. So the slope, rise over run, is negative 4 over 2, which simplifies to negative 2. So again, y, and then we have our mx plus b. There is, this one is a solid line, so there's going to be a line under our inequality. And this one is shaded above, again. So above means greater than. So therefore, those are our 2 inequalities. That's our system of linear inequalities that represent that shaded region. All right, I hope that this short lesson has helped you, and have a great and fabulous day.